Hello, Mr. Yashar, and maybe also my friends, of course, if you watch. Um, I'm İlknur, and welcome to my presentation of week 11. Um, we have 8 topics in this week, um, so let's continue with Zoom. Hello again, welcome to my presentation. Here are our topics, and let's start with relativity. And this is the process. And in this presentation, I will talk about some process, some developments that occur mm, before the time. Also, just developments. Okay. The old physics, and so before the 19th, people followed the rules by Newton, thinking everything moved the same way, and light needed an invisible thing called ether. Ether, maybe you remember it. Confusing light experiments. Some scientists tried to measure how Earth moved through this ether using light, but it didn't work as expected. So then Einstein had new ideas, and he said, "No more ether, and the speed of light is always the same, no matter what." Then he said also, even if things speed up or feel heavy, it's the same as the gravity, all part of space and time. Okay. It's a relativity theory called also. And cool effects, really, really big things like planets can bend light and we can see it during certain events. Okay. Now we believe that. After doing lots of tests, everyone agrees with Einstein. His ideas are like the superhero rules of the universe, like relativity theory. In Turkish, izafiyet teorisi. Okay, the next topic is age of the Earth. Um, for years, this topic has many conflict, has many theories. Like old ideas, Aristotle thought Earth was existed, uh, and people had different beliefs. Yes. So okay. Some thought that could figure out Earth's age from the Bible, but they said it was created in 4004 BCE. And others like Buffon, Gust's Earths are based on how fast things cool down. They said around mm, 75,000 years. And after the radioactivity discovery in the late of 19th century, scientists found that a better way to figure out the rock age using the radioactivity. They found all this rock is about 2,960 million years old, and 12 crystals called zircons are around 4,000 300 million years ago, and based on the meters, and they cost Earth is about 4,600 million years old now. It's the guessing. Okay, and the size of the universe. First, we talk about Earth and then universe. It's also a topic that mm, that everyone think about it. Almost everyone, almost every scientist think about it. It's also a process. It's starts the old year old earlier. Sorry, my tongue. Okay, but with the telescope in the late 1700s revealed fuzzy patches in the night sky called nebulae. Yes, in the early 19th, astronomers discovered that many nebulae were actually was systems of stars like our Milky Way galaxies. Yes, in this picture. Yes, I'm sorry, just covered it. Okay, and philosopher Immanuel Kant in 1755 had suggested the idea of island universe. George Gamow, Ralph Albert, and Robert Herman developed the Big Bang theory. Then, as you see, there are a lot of several theories and thoughts. Yes, they just think. Quantum are the next topic. First, it's also a process. Always new scientists come and develop it. Develop. Yes. First, Newton showed that white light is made of the colors using a prism. And late 19th century, scientists struggled to explain how to heat objects emit light. And Max Planck's quantum idea is light is emitted in small packets called quanta. And Niels Bohr quantum model is said electrons move in specific orbits and explained spectral lines, which is correct. Yes, quantum numbers and spin. Sommerfeld added quantum numbers, Beck and Goldsmith found electron spin. Pauli said no two electrons in an atom can be identical in all respects. And Heisenberg said we can't know both the position and moment of a particle at the same time. Yes, it's right, we can't. We couldn't. In post-World War II, physics developed quantum electrodynamics for precise particular behavior calculations. Yes, by the way, World War II is important for developing some scientific and technological developments. So, this journey from Newton to modern quantum theory explains how our understanding of lights, atoms, and particles evolved over the time. It's just a journey. Okay, early digital computers. Digital computers were first seen in the late 1930s and early 1940s. By using binary numbers to represent numbers and characters and to perform calculations. Binary numbers, I mean 0 and 1. If something is correct is 1, something is false is 0. Yes. George Spitz built at his home a very simple adding device that could add two binary numbers. This is the first digital computer. Subsequently, Bell Labs developed. Oh, he also a member of Bell Labs. And then Bell Labs developed several other calculators, of which BLT Model V completed it 1946, continued to 9,000 relays and weighed 10 tons. Also in Germany, some works about computers, calculators developed at the same time. So developments and not just in United States, but also in Europe. Yeah, the the Manhattan Project. Guys, do you know this man? He is Oppenheimer. Um, did you ever heard him or did you go his movie? I did, yes. This project was created for manufacture first nuclear weapons in World War II. And the project involved numerous physicists, including European scientists who had felt the Nazis. And the project achieved the first experimental nuclear device explosion in July 1945 atomic bomb was dropped on the Hiroshima and Nagasaki. Unfortunately. Okay. There's many things to say, but I don't know. The first working computers. ENIAC was built in United States at the University of Pennsylvania's Moore School of Electrical Engineering. Completed in look at this. Completed in 1945, ENIAC was designed for calculating projectile trajectories, initially for military purposes, during the World War II. So what are we see? But in World War II, there's some developments for military. So developments is developments. And our last topic, scientists and defense. The role of scientific and technological developments during and after World War II is too much. The impact of radar, the creation of the first electronic computer by the United Kingdom, German technological advances, the Manhattan Project's role in developing the atom bomb, and the arms race that followed. It's important. And in summary, there is a connection. We can say it. There is a connection among science, war, and scientific, societal concerns during this period. Okay, and we can understood that even wars, wars can be important role in technology and developments, as you see in this presentation. Okay, guys, thanks for your attention and see you soon. Bye.